All right, so we're going to try an example now where we write the equation of the parabola given what we know about the focus and the directrix. Now, in the previous video, we discussed what the focus and directrix looks like on a graph. Actually, I think I still have it on this PowerPoint, so let me just go back a slide or two. The focus and directrix. All right, so the focus is a point that's equal distance to the vertex as the directrix. I said that right. So every single point on our parabola is going to be the same distance from the focus as it is to the directrix. And that key piece of information is going to be very useful to us. So any point on the parabola is the same distance from the focus as it is to the directrix. And we're going to use that information for distance to solve this today. We're going to be using the distance formula. Now, the distance formula, if you don't remember, it'll be on the slide in a second, but it's absolute value of x minus x1 squared plus y minus y1 squared. So if we know where the focus is, which the equation tells us here, it's at 2, 4. It says F2, 4. I'm guessing the F stands for the focus point. Points at 2, 4. And our directrix is at y equals negative 4. We're going to be able to use that and set basically these two distances equal to each other. So PF and PD means the focus, or distance from the focus, is going to be equal to the distance from the directrix. Okay? So our distance formula, this is how we'll set up our problems. Okay, so make sure you note that. Again, we're setting it up this way because we're going to call this the distance from the focus, and this is going to be our distance from the directrix. Okay. And again, we're doing this because we know that the distance from the directrix is supposed to be the same as the distance from the focus for every single point on the parabola. So if I have the two distances equal to each other, or find out where they're equal to each other, I'll be able to write the equation for my parabola. So what we're going to do is now just plug in a couple numbers and evaluate some things. But of course, we do want to be careful in that process as to not mess anything up. So we're going to plug in our x1 and x2. The focus here is going to be our x1, not x1 and x2, our x1 and our y1 values. So we're going to use the 2 for x1, the 4 for y1, and we're going to put that in the distance side of our formula. So our equation will have the same thing. We'll still have x minus, but x1 is going to be 2 squared plus y minus 4, since y1 is 4 squared. All right. Now keep in mind that the minus sign is a part of this formula, and it's still going to be there in our equation unless the focus was a negative number. Like for instance, if this was negative 2 instead, I would be subtracting negative 2, which would then turn this into a plus sign. So it can be a plus sign, but it's only going to be a plus sign if the number is negative. Obviously these weren't, so we just plugged them in, we kept the minus sign the way it was supposed to be kept, and we're going on with our business. Now on the other side, we're going to plug in our information for the directrix. We know the directrix is at y equals negative 4. So this is going to be basically our y2 value. Do we know what an x2 value is? No, we don't. Because the directrix is a line, and the x value is going to be pretty much every x value. Because if you look at the line, y equals negative 4, it would be something like this. Obviously, you have a point for everywhere on the x scale. It's always just at negative 4. So x is pretty much every single number. So that's why it's not really important for this one. We're going to just keep going. Plug in x minus x. So x2, we're just basically going to call it a regular x. Or really not plug anything in at all. Y minus y2. Now y2 is a negative 4, right? So if I subtract negative 4, this is going to become plus 4. Apologize for the dot. That's kind of what we're talking about when I said earlier about, if x was a negative 2, for instance. If it is negative, you're subtracting a negative, which is going to mean you have a plus sign in your equation. Don't forget the square root here. All right. Now, what we'll do real quick is notice x minus x. that's going to be 0, right? It's going to be 0 squared, and 0 squared is going to be 0. So essentially this whole thing here is going to be gone because it's going to become 0, and only leave us with the square root of y plus 4 squared. That's what we'll pick up on the next slide. So our next slide, it's set up like this. Again, because we don't see the x minus x on this side anymore because, like I just said, it turns into 0. X minus x is 0. 0 squared is 0. It disappears. All right, so we're left with this. Now what we're going to do, let's go ahead. We can square both sides just to remove the square roots. Okay. So when I square this side and I square that side, it simply removes the square roots and leaves us with x minus 2 squared plus y minus 4 squared equal to y plus 4 squared. But no square roots. All right, so what we're going to do is we are going to basically expand the y portions here. We're going to leave the x minus 2 squared as x minus 2 squared, but let's expand the y part here. So let me bring down my x minus 2 squared. I don't want to change that, but let's expand y minus 4 squared. Now y minus 4 squared is actually y minus 4 times y minus 4, right? And same thing for y plus 4 squared. It's going to be y plus 4 times y plus 4. So when I say expand, that's what I mean. Like, separate them out. Now let's multiply these groups out for the y's. So the y times a y will become a y squared. The y times a negative 4 becomes negative 4y. Negative 4y will become negative 4y. And that'll become positive 16. Equal to, same thing over here, let's expand. Y squared plus 4y plus 4y. And then plus 16. I'm going to bring my x minus 2 squared down. Don't forget about that. Again, I don't want to expand this. I'm only expanding the y's because there's y's on both sides. Essentially is the reason here. I'm not going to expand x. You'll see once we get to the answer why I didn't expand x. But expanding the y's simply because there's y's on both sides. There's a group of y's on the left. There's a group of y's on the right. So let's expand them and let's start simplifying and canceling things out. If we start putting just these together, the negative 4y and negative 4y will become a negative 8y. Right, let's leave plus 16. Let's leave the y squared. Let's leave our x minus 2 squared. Okay. We can go ahead and combine these like terms as well. Y squared plus 8y plus 16. Now, if there's anything that's on the left that's the same on the right, then those two terms will cancel out. So I see a y squared on the left, I see a y squared on the right. Those two are going to end up canceling each other out. Because it's basically like saying, x plus 5, equals a plus 5. Well, yeah, plus 5 is going to equal to plus 5, so it's kind of useless information, and we're going to know at the end of the day that x is going to be equal to a anyway. Because essentially what you can think of this is like, that's, oh man, I didn't even do that, but it's still up here. Let me just, here we go. Basically, think about subtracting y squared on both sides, right? If you want to move this y squared over there, you'd be subtracting it, right? You subtract y squared on this side as well. But notice, y squared minus y squared is 0, y squared minus y squared is 0, so it essentially cancels out. So just look for the things that are the same on both sides. Y squareds are the same. I also have plus 16 on both sides, which means they're going to cancel out for the same exact reason. If you were to subtract 16 on this side and this side, you'd end up canceling them out. They become 0. So really, what we're going to be left with is x minus 2 squared minus 8y equals positive 8y. Now we're nearly there. Notice we can't cancel the 8y's because this is a positive 8y and this is a negative 8y. So they don't cancel like the y squareds and the 16 do, because 8 is not the same as negative 8. So that's why they're still here. Well, we can combine our y's. We can add 8y to both sides and end up having, the x minus 2 squared equal to 16y. And now all I got to do is get this y by itself. I'll divide away that 16 that's on it. and I'll have y equals essentially this. Y is going to equal, how we're going to write those, we're going to write the 16 as its own fraction. We're going to write the 1 over 16, and then we're going to have the x minus 2 squared. Because this looks more accustomed to what our vertex form looks like, right? The 1 over 16 is representing basically the a value. So that's why I'm writing it like this rather than like this over here, as you can see that I've circled. It still means the same thing, but I'm writing the 1 over 16 to 16, basically the fraction part of the 16 as its own piece, sort of separate from the x minus 2 squared that was there. It's still the same thing, it's still dividing by 16, but it's kind of off to the side, just for the sake of being very similar to our vertex form. Remember vertex form we talked about previously was like this? So writing it with the 1 over 16 basically means the 1 over 16 is your a value. And that's going to be good information in the future. And of course you can see the x minus 2 squared, so the x minus 8 squared. There's no plus a here, but it's all good. Alright, and so that's going to be, that covers it. So if we just quickly summarize what we did, I'm going to erase what's here because it's still going to be on the slide anyway. If we summarize what we did, okay, it is kind of a long process, but it's broken down into little steps. So set up the problem with your distance formulas. All we do here is plug in 3 numbers. We plug in the x1, the y1, and then this for the y2 because it's the y value. So we just plug in that number there, that number there, that number there. This canceled out because x minus x was useless, and that's why we started our next slide with this information. Now, at this step, all we did was square both sides to get rid of the square roots. Now, this step's probably the hardest part of them when you get to this point because you have to multiply out your groups for y's, the y minus 4 squared and the y plus 4 squared. We had to expand them. So that multiplying is going to be kind of the heavy load of work, but we know how to FOIL, we can do that. You just have to remember you're doing it twice here. Okay, so we did the y minus 4 times y minus 4, and it got us this, and the y plus 4 and y plus 4 got us that. And remember, at that point, all we did was we canceled out the things that were the same on both sides, okay, and rewrote our equation a little bit smaller, a little bit easier to work with. I combined the y's by adding the 8y to the right-hand side, and then I divided by 16. It's the very last step to get that 1 over 16 x minus 2 squared. All right, so it is long, but don't be too intimidated by it. All the steps are outlined here. Any other problem that you work out kind of follows the same exact process. So good luck to you. There's still more to come with Focus and Directrix. That will be probably in tomorrow's video. So I'll see you guys later.